Hey, in this lesson, we're going to talk about how things dissolve or dissociate. So substances can dissolve in water in three different ways. And one way is to go through dissociation, which is where they separate or break apart. So if you want to, you can click on this link right here to watch a quick video. So dissociation is separating or breaking apart, and ionization is when they separate into actual ions. So for a solute, which is what you put into the solution, what is going to be dissolved, the solute and the solvent must attract each other. So like hydrogen and oxygen and chlorine and sodium. So right here you've got salt and water. So you've got a water molecule and you've got sodium and chlorine. And what happens is because they're attracted to each other, they break each other apart when they get into a solution and dissociate. So when we talk about the word solubility, what we're talking about is the ability for a substance to dissolve in whatever we put it in. So if we're talking about the solubility of salt, we're talking about how well it will dissolve in, let's say, water. Or how well the solubility of sugar would be how well it would dissolve in whatever we're putting it in. So the solubility of sugar in sweet tea, when we pour the sugar into the hot water and tea, we know that a certain amount will dissolve. Okay? So the maximum solubility is the maximum grams of solute that will dissolve in 100 grams of solvent at a given temperature. So this is going to vary based on a couple of different things, especially temperature, because we know if we increase the temperature, we can always dissolve a little bit more stuff. So if you continue adding sugar to lemonade, there's going to be a point where the sugar is going to fall out on the bottom and precipitate, and no more is going to dissolve. And these excesses are going to dissolve out in the bottom. So in 100 grams of water, look at this picture right here. We've got salt in water here. We've got sugar in water here. So we're looking at solute A first. We've got 1 gram of solute A, salt, and it dissolves completely. If we add more than 1 gram, the additional amount is not going to dissolve and it's going to come down in the bottom. Let's look at sugar. In 100 grams of water, 3 grams of solute B will dissolve before 2 more grams also dissolve before any additional solute would fall at the bottom. So you're thinking these are both the same amount of water. Why can we dissolve more sugar than we can salt? Well, it's because sugar's a different molecule. It's got a different composition. So every single solute that we talk about is going to have a different solubility. It's going to have a different amount that dissolves. So if your temperature of the solvent is the same in both, you can conclude that solute B is more or less soluble than solute A. So let's decide this. I can dissolve more sugar in water than I can salt. So solute B is more, I'm going to drag more down here, soluble than solute A. Okay, now let's talk about concentration. Really, being concentrated is something that's very simple. So the more concentrated something is, the more material we have dissolved in our liquid. So you know some people like their tea really, really sweet, and some people like it kind of watered down. Our darker teas are going to be sweeter, where we have more sugar, more tea dissolved, it's more concentrated. And our lighter ones are the ones that are more diluted or watered down. So dilute solutions have very little solute. So let's imagine Kool-Aid. A dilute Kool-Aid would have a very small amount of Kool-Aid powder. A very concentrated solution would have a large amount of Kool-Aid powder, a large amount of solute dissolved in solvent. So how can we make a solution more dilute? Well, we could add water. So you type add water right here. How can we make it more concentrated? We could add more solute. We could add more solute. So if I'm doing Kool-Aid, I could add more Kool-Aid powder to my solution. All right, so let's do this part right here. We're going to list the items in the bank and tell where they go. So if we add more water to instant coffee, it will make the coffee darker. If we add more water, that's going to dilute it. So that's going to be false. The concentration is the amount of material dissolved. Now, if we look right here, it says concentration is the amount of material dissolved. So that's going to be yes, true. To decrease concentration, add more liquid. Yes, that's true. If we add more water, we decrease the concentration. We dilute it. To dilute means adding less water. No, dilute means adding more water. To increase the concentration, add more solute. Yes. And you typically have more solvent than solute. That is true. Typically, when you're talking about Kool-Aid, you have more water than actual Kool-Aid powder. You have a whole pitcher of water, but you have only a little packet of Kool-Aid powder. So concentration can be measured a couple ways, percent by volume and percent by mass, which means how much of what we are looking at is actually our solute. So if we have a 10% concentrated solution, that means out of 100 milliliters, 10 milliliters are going to be juice, 90 milliliters are going to be our solvent, water. If we do it by mass, like if we have sugar and tea or salt and water, we do it by the weight. So like we have 20 grams of salt and 100 grams or 100 milliliters of water. So it's 20% concentrated. And if we're looking at the concentration again, if you have 70 grams of NaCl and 250 milliliters of water, we always can take our solute, divide by our solvent, and get our concentration. So let's look at this problem right here. Solution A has 50 grams of NaCl and 250 milliliters. Solution B has 100 grams. So we have 50 grams of our solute here, same amount of water. 100 grams of our solute here, same amount of water. So all we do is divide here and type the number right here. So do 50 divided by 250, type your number. 100 divided by 250, type your number there. So there can be three types of concentration. Think about a towel when we're talking about this. We've got a saturated towel is holding all of the water that it can hold. We can't wipe up anything else with it. Unsaturated means it's not yet saturated. So think of a towel that you've wiped something up with, but it's not yet saturated. And a supersaturated means it's dripping. Okay, there's stuff falling out. So solutions can have the same thing. So unsaturated solutions mean, hey, we could put some more Kool-Aid powder in here. It's not all, we could add some more before it falls out. Saturated means we've got all that we can hold. Everything's dissolved, but we can't add any more. And supersaturated is when you have so much solute, so much Kool-Aid in your solution that it falls out at the bottom and forms these little crystals. And you've seen that happen when you've made either tea or lemonade and you put too much sugar in it, it falls out at the bottom. Okay, so saturated solutions hold all of the solute that it can at a given temperature. So at 0 degrees, this can be true with compounds too. Okay, so NaCl is a compound, sugar is a compound. At 0 degrees, we can only dissolve 23.1 grams of copper sulfate in 100 grams of water. At 20 degrees, we can dissolve more. At 100 degrees, we can dissolve more. What you're seeing here is if you increase the temperature, you can dissolve more stuff, more solute. So as temperature goes up, we can dissolve more of our solute. If we're going to add more grams at those temperatures, all is not going to dissolve. You've got to increase the temperature if you want more to dissolve. So if we're unsaturated, remember unsaturated means we're not yet saturated, we can dissolve more solute at a given temperature. So let's say you have unsweet tea. How could you get more sugar to dissolve in it? Well, one thing we could do is we could heat it up, increase the temperature. And then we have supersaturated solutions. Supersaturated solutions, remember, is where we have too much stuff in there and it forms a crystal. So watch this video really quick on how to make supersaturated solutions. And lastly, we're going to talk about conductivity and concentration. The more concentrated your solution is, the more conductive it will be. So if you have a really, really concentrated solution of, say, salt and water, it's going to light up a light bulb or conduct electricity better than a solution that doesn't have very much salt in it. So the more concentration, the more solute you have in your solution, the better it's going to conduct electricity.